In this video, we're going to talk about using Linux commands on FortiGate firewalls. So just a brief intro, all Fortinet firewalls run on FortiOS, so this is the operating system for FortiGates. And under the hood, it's essentially just a modified Linux kernel, but you don't get a full interactive shell as you would with a typical Linux server. But there are some commands that we can run directly on these devices. So most of the time when we're troubleshooting a FortiGate on the CLI, they have the FortiOS commands like get and show and diagnose and some others. But if we need deeper visibility, especially when you're working with TAC or engineering on some issue, or if you want to understand what's happening at the system level of the device, or even if you're trying to identify potential IOCs on the device, these Linux commands can really come in handy. So in this video, we're going to walk through the commands, kind of show what information you can see and look at some output and go through some use cases for these Linux commands. Some considerations also before we start is to run these commands you need to be logged in as an admin with the super admin profile assigned. On VM FortiGates you need a full paid license, so if you have an eval license it's not going to support this. This is also a CLI only feature. There's no like GUI equivalent where you can view this information. These commands also run locally on the FortiGate that you're signed into. So if you have an HA cluster and you want to run the command on the secondary unit, you're going to have to sign into that device directly to view the information. Tab complete is also not available with these commands. You can also use these commands in automation stitches by using the CLI script action type. If your firewall has FIPCC mode enabled, these Linux commands will not work. And the output that you see may depend on the model of FortiGate you have and the firmware version. So just for reference, we're going to be doing this on a FortiGate 90G, and the firmware version we're going to be running is 7.4.9. Okay, so now we're in the firewall command line and we can run some of these commands here. So we're going to start with some system identification and health commands. So the first one will be to get the Linux kernel and build version. So that'll be this command, fnsysctl cat, and we're going to cat the proc version file. So we can see here we're running 4.19.13 and we can see the build timestamp. Next, we can use this to get system metric information. So to view the CPU details, we can run this command here, cat proc CPU info. So from here, we can see all of our CPU cores. So on a 90G, that's 8 total. We can see the model, which is the FortiSoc 5. We can see that these are 1600 megahertz CPUs. Right, so this is useful for knowing the hardware that we're running, and we can do the same thing for our memory by doing the same command, but this is going to be memory information. So we can see the total RAM we have, the available RAM, we can see buffer information, we can see our cache value, so we can get a full glimpse into the total memory usage on the firewall. Next, we can try to look at some more files. So these files are readable, as you can see, but some files, and actually many files in the file system on these firewalls, are unreadable. So for example, we can do this one. So this file here is essentially a temporary backup that the FortiGate keeps for certificate and key operations. So this probably contains some sort of private key material, so it is protected even though it's in the writable temp directory. And lastly, we can run a command to look at the local TCP sockets. So that will be, if we just up arrow under the proc directory net TCP. So here we can see all of the open sockets to and from the FortiGate itself. And this is a bit difficult to read. This is all in hex output, but this is useful for some advanced troubleshooting scenarios. So we can see here, for example, this state here means listening. So we can see that these are all listening. An easier way to view this isn't a Linux command, but this is just a FortiOS command where you can see the same thing. Is a diagnose TCP sock. So we can see this is the same output, but in like a more readable version. But still, when you're debugging issues, it's good to look at both of them and compare these. Okay, so now we can move on to some interface configs. So we can actually run ifconfig just like you would on a Linux box. So you can do the command here, fnsysctl ifconfig. And we can see we'll get just your classic ipconfig output for all your interfaces. And this is for physical interfaces. This is also for logical interfaces. We see some more logical interfaces here with all the addressing. So you can use this to identify port errors and transmissions and MTU values, and you can even do this for specific interfaces. So I have a few connected, so like my WAN 1 I can see. We can do my server network, which is on port 5. So that's pretty much it for interface Linux commands, but still something useful to be able to do. So now we can start doing some file system commands. So right off the bat, we can print our working directory. There's really not much you can do with this. Like we can see here, we're in the root. You can't CD around like you would in a typical Linux server, but at least we can see, as we stand right now, we are in the root directory. We can also do ls command. So we can see here just a high level inventory of the core directories. Just good for reference. This is good to be able to navigate this because for certain CVEs that are released, Fortinet will actually release certain files to look for as IOCs, so any unexpected files or modified files or any scripts in here. So it's good to have access to this and to be able to navigate through this. So just at a quick glance, right, we can just see some of the system directories. Like we can see our bin and sbin for our executables and utilities. We see etc for our system config, var for our logs, temp for our temporary files, right? So just some examples there. So we can actually read some of these files. So if we do, for example, we can do a flag AL on the temp directory. So we can see, right, just in typical Linux fashion, we have our permissions, we have our ownership, our groups, timestamps, size, and file names. So we see a lot of, for example, these SR, WXR entries. So these are the domain sockets. So these are like the local IPC endpoints for the daemons. So seeing a bunch of those in temp is normal. We see some .message files, .route files. So these are like the hidden runtime artifacts. Again, this is all normal stuff. We can see some .pem files. So this is for storing certificates and keys. We saw previously that these are not readable, right? So some of these files will be readable, some won't. And so this is good to know, because if you see something in here that's out of the ordinary, then you might have a situation on your hands. So we can try another one with just the A flag on the temp directory. And we can see what this essentially does is we're reading from the same directory, but we're just showing the names, including the dot file. So this is just quickly telling us, you know, what's in this directory without all the permissions and the timestamp details. So next we'll move on to some more file commands. So now we can continue on with some more file system commands. We can do the du and the dh commands. So in Linux terms, df is going to tell us what file system is filling up, and du is going to tell us what directory is actually consuming the space. So we can just do a quick example here. If we do a df-h, so the h is going to basically put this into human readable format. So it's going to show us the size of the files in actual megabytes and gigabytes instead of just raw blocks, which will tell you what file system is filling up. So just some things to point out here. We can see the file system, we can see the size of the file, the amount used, the amount available, the percentage used, and where that file is actually mounted on the operating system. So we see some multiple entries here, for example, none. So we see some temp directory, dev, shm, dev, cmdb. So when you see none, it's typically a RAM-backed or runtime mount and not on the physical disk. The real persistent storage is on the MMC partitions. So for example, right here, this is mounted on data and also mapped into jail paths. So we can see that's 59% used. And we can use that to really determine what file system is impacted if something's consuming space. So next we can do the du command. So this is going to show us disk usage by directory. So this is going to walk the directory tree and print the space used per path. So you can see here when I enter this, it's going to be extremely verbose and isn't always the best to do if we're doing any sort of diagnostics or troubleshooting. So we can see here, right, like the left column is going to be the size, and then the right column is the directory path itself. So, that's a lot of output. So we can filter on this a little bit. So we can do, for example, if we put the S flag, that stands for summary. So what this is going to do is we're basically telling the device to give us the single summary number for the current directory. Basically, how big is everything under here without listing the entire tree. So we can see the output here. The dot indicates current directory, so basically the whole root of what we're scanning. And then this is our data value. So you can see this is about 720 meg of total usage. So this is good for getting like a storage baseline, like before and after checks, or comparing your disk usage over time. But this doesn't tell you where the space actually is. So to do that, we can use this command here. You can give it the D flag with 1 and A. So D1 is limiting the output to 1 level deep. So it shows me the top level directories, and the A flag includes the files too, not just the directory. So this is going to make the DU output more readable. So we can see, for example, data 2 is consuming the most space here compared to all the other ones. So some more DU flags that are available is, for example, -L. So the L flag is telling it to follow the symbolic link. So this is useful when you suspect a directory contains symlinks that are pointing to real data elsewhere, and you want DU to count the target content. So we can see, just like the commands before, this is really verbose. So we're not really going to go through all of that, but what we can do is drill a little bit deeper down on that data 2 directory that we saw, right? So this was the one that was consuming the most space. So we can see here, when we do the D2 command, we're going 2 levels deep from data 2. So we'll get all the top folders and the next layer under them. And then A, again, is going to include both files and directories, so we can spot a single large database or package files, for example. So next we can look at a command just to show the system time. So this one's pretty simple, but it's still important. So if we just do system control date, this is going to just print the FortiGate system date and time in the Linux style format, and this is going to ignore options and flags. So it's simply just show me the current clock command essentially. So the reason you use this is for log correlations, so just to make sure that your log timestamps are lining up with the system time. Same with your debug outputs, packet captures, crash logs, automation logs, whatever it may be. If your clock is wrong, it's going to mess up whatever investigation you might be doing. So we can just see here that it's telling us it's Tuesday, December 30th with our time and date. So if this doesn't match reality, you should check your NTP config and your NTP state just to confirm that your device is using the right time zone and is synced with NTP. Otherwise, your logs and packet captures aren't going to line up with what you expect. So now we'll move on to system processes. So, typically we can use the FortiOS to show our system processes with the top command. So that's what you might be used to seeing, but we can also use the underlying Linux system to do this. So if we do a system control PS, we get a more verbose output on all the processes that are running on the device. So we can see our process identifier, we can see our UID and GID, we can see the state, and we can see the command or binary name. So for state, R is going to mean that we can find one that's in R state. Like this one, for example. This means it's running and is actively executing on the CPU. S is for sleeping, meaning that it's waiting on something. And I means that it's idle. So this is all normal. So we can use this to confirm that a daemon is actually running. We can see if there's too many instances of something running. And then we can also grab the process identifier and then kill it just like you would with the diagnose commands. So for example, if we do a diagnosis top again, we can see, for example, the WAD process. So if we want to kill that by process ID, we can do a diagnosis kill 117248 for the top one. And that's in the crash log. So if we do like a diagnose crash log read, we can see when we actually killed the process. So that's a loggable event when you do it that way. It's also worth noting that that most of the processes on FortiGate are run via watchdog, so when you kill them, they will restart immediately after. So if we go back to the Linux command version of this, we can see our WAD processes here and their identifier number. So we can kill them this way as well. So if we do kill, we can just put in the process ID. So for example, 7232. Alright, so that'll kill the individual daemon. And then we can also kill it by name to kill all the processes under that name. So if we delete this and just do WAD, or kill all WAD, that's going to kill all of them. And what you'll notice is when you do it this way, that's not going to show in your logs in the crash log debug. So that's just something to keep in mind. So if you're trying to keep an audit trail, just be aware of that. So now we'll cover environment variables, and we'll also cover searching using Grep to actually parse through some of the large data sets that we're seeing. So real quick, we can do the print environment command. So this is showing us the environment variables on the FortiGate. So we can see here, this is our terminal, and we can see here, this is my session coming from the HTTP CLI socket. So this is you'll see this when you're connected via the GUI or HTTP. So, this is a rare command to run, but it comes in handy if you're like troubleshooting session context, or you're having weird shell behavior, you want to see if everything looks okay, or if you want to see how a CLI session is actually spawned. So now we can use grep to actually parse through some data. So we saw before when we were looking at some of the files we were reading that they had some really verbose output. Well, if you know exactly what you want to search for, you can use grep just like you would in normal FortiOS syntax to actually pull certain information. So for example, if we want to pull the total RAM, we can use this command. So the N flag is to print the line numbers, so I like to use this to reference exactly where that value came from. So you can see here we're reading this file, we're looking for this variable, and we can see that's on line 1. So there's some other information we can do here. So we can look for the free memory, so that's on line 2, so we can see the available memory on the system. And we can also maybe do cached, so we can see how much memory is cached, and then one more we can do buffers, right? So if you know exactly what you want to look for, you can use this to pull that information without dumping the whole file and then having to read through and pull what you're looking for. So we can do the same thing for example, if we want to get the CPU info. So basically what we're doing here is we are using the C flag to count the matching lines. So we're basically saying we want to know how many processors. So we can see on this 90G we have 8 CPU cores. So that's a quick way to use Linux to pull that information. What else can we do here? We can do, for example, we can throw in the model name and we can get the actual model name of our CPU cores. We reviewed this before on getting the Linux version, but this is just another way to do it, right? So we can see that we're running 4.19.13 with the build date. We can look at using the B and A flags for before and after matching. So we can use the B flag and A flag to show the lines before and after the grep match. So for example, we can just use the command we ran earlier to look for the cache data, but we want to look for the 2 lines that precede it. So that's going to show us the lines that are 2 above the value we're actually searching for. And then we can do the same thing with the A flag to look at the lines that match after the value that we're matching for. So we can see here we're matching on mem total, and we want to see the 3 lines that follow that. We can also use I for case insensitive searching. You can see a lot of these values that we're searching for. Some have capitals, some don't. So it's good just to be able to use this in case you're not sure. So we can, for example, use the same command but use the I flag. So that way, even if we don't know the casing, we can still see that. So, this is grep is a powerful tool. So if you know exactly what you're searching for, especially after you start dumping those files with all the output and you know what values you might want to search for specifically, you can use grep to make your output more readable and manageable. So next we'll get into some more advanced troubleshooting, and we'll take a look at NTurbo. So if you worked with FortiGate firewalls for some time, you probably know what this is, but essentially the NTurbo is a performance feature that helps traffic move efficiently, right? So it keeps inspected traffic moving at a high speed, essentially. That's the point of it. So if you're troubleshooting things like IPS throughput or performance issues that only are impacted when you enable inspection, the NTurbo counters can give you an idea if the packets are flowing cleanly, or if you're getting queue drops, or there's buffer errors, or transmission hangs, or something like that. So this is a 90G, like we said. Not every FortiGate has NTurbo in it. So we can actually use the Linux command to see if it's present, and we know it's going to be present here. So we're looking at this file, and we see the presence of these files, right? So if you didn't have NTurbo, this would basically just return an error that the file doesn't exist. So we know that it exists here. So what we'll do now is we can see what files are actually available for this interface by reading the 0 file that we see here. So we see 2 read-only files, dev and drv. So this drv one is going to be the one that actually has data about the NTurbo process. So we can pull the statistics by reading this file here. So we'll do that, and you can see that I don't have any NTurbo offloaded traffic active. I don't have, this is a almost factory reset firewall. I don't have any inspection on the policies that are on it at the moment. So you can see here the data we can see. So this is what it'll look like if you're not using NTurbo at all. You're not doing any inspection. So we can see the driver, RX and TX. So this is the total packets that are handled by the NTurbo currently. We can see the TX hang. So this should be no. If this was yes, that means that packets are stuck. We can see free and used buffers. So this is how many packet buffers are available versus the ones that are currently in use. We can see allocation failures. We can see queue readiness. So this is the bit mask of the queues that are active and ready. And then we can see the transmission lines. So we can see in and out. So these are the packets that would be entering and leaving the queue. We can see drop values. So this is packets that are dropped at the queue. So if this is rising in number, that's a bad sign. We can see NRDY. So this is queuing not ready events. So if your firewall is under a heavy load, you might see a value here. And we can see a couple other values here. So what I can actually do is we can go to, I have this test firewall policy. So this is my WAN, and then on port 5 I just have a Linux server connected to it. And what we can do is we can just enable the default IPS profile for now, just so we can actually start doing some inspection. So we'll enable this, and then I'm going to generate some test traffic and let this run for a few minutes, and then we'll come back and essentially compare. Okay, so as you can see, I ran some test traffic through that Ubuntu server, and we ran the same command to view the NTurbo statistics, and now we can see that there's actually data here compared to before. So we can kind of go through this and what some of this means. So we can see here, so this is confirming that NTurbo is actively being used with our IPS inspection enabled. So we pushed a couple hundred packets through NTurbo, and the totals match, right? So we have 247 in and 247 out. So that's good. Again, this is set to no. So if this ever flips to yes, that's a flag that the transmit side is stuck, and you'll have to look into that. We can see here the buffers. So the buffers look stable. We have plenty of buffers and a normal amount in use, and we have 0 buffer allocation failures, which is a good sign that we're not under any memory pressure in this path. We can see that our queue is active and balanced. We can see equals in and equals out, similar to here. So we have 57 in, 57 out, 59 in, 59 out, and this all matches, which is what we want. So it means that our packets are not getting stuck in a queue, so they're successfully entering and leaving. We see 0 drops, we see 0 no ready events, and 0 buffers. So this is what you want to see. So when we have IPS enabled now and the traffic is running, our NTurbo looks healthy, our counters are increasing, and everything stays matched. No drops, no buffers, no errors, and no queue buildup. So it means we don't have an NTurbo bottleneck. If you did, you would have to look into the amount of inspection you're doing and see if you can make any adjustments to that to fix the NTurbo issue.
So now here's just a quick example of what we can actually do with some of these commands. So I'll kind of just go into more detail on some of the stuff we already covered, but in sort of a real life example demo almost. So we can look at the sockets and get a better idea of what's actually listening here. So we can use the same command, system control cat procnet TCP. So this is going to show, right, the FortiGate's local TCP sockets in Linux format. So the IPs and ports are shown in hex, and the ST column is the socket state. So 0A is the listening state. So we can see that really the majority of these sockets are already in a listening state, but if we want to filter on the ones that are actually in the listening state only, we can grep out the OA. I like to do it this way because if you do it without the space, you might get like one of these in there. So like this guarantees that you only get the state. So you can throw a space in there like that, and then we can run that on the TCP file. And then that filters out all the local TCP ports that something is actively listening on. So what we can do here is kind of look through these, right? This is in hex, so it's a little bit hard to read. But if we scroll, we can probably find one like here, for example. So 0035 that's 53 in hex. And these zeros stands for 0.0.0.0. So this means that it's bound on all interfaces, and it's listening on TCP port 53. So we can filter on all the DNS listeners with grep. So if we do the N flag, and we throw in that hex value for 53, and run it against this file again, we can see we have one DNS listener on the firewall. And there's like other common ones that you should know. So for example, we can try SSH, which is 0016. That's hex for 22. So we can see we have a few of those listening. We can try 443 should be 01BB, and we can see there's also some there as well. So we see these are listening on all IPs, and we can see this one that is actually has a value here. So if I convert this is 10.16.1.1. So this gives you an idea of what interfaces are listening on what services. So we can also check some TCP health counters. So we can do that against the SNMP file. So we can do fnsysctl grep n flag, and we can do TCP against the procnet SNMP. So we see here we have 2 lines. So this is basically showing the kernel networking stats. And the reason we put this caret here is because this returns 2 lines. The first is the column names, and the second is the live values. So what we can determine from this output is the cur stop value is 5. So that's the current established TCP sessions at the kernel level. We can also see the retrans segment value is 0, so that's good, which means we don't have any retransmits.